Hello everyone. Today we are going to see predictive delivery time analysis, which is an estimation in last mile logistics for my project on managing machine learning projects. So the evaluation criteria for this project is going to be based upon 5 different steps. So we would talk about opportunity evaluation, trying to understand what the problem is, whether the opportunity is an attractive use case for an ML solution, and is there a real problem that exists today and how we could solve it. And we will dive it into crisp DM business understanding methodology, where we will have a couple of different steps that we will walk in with each and every one of those subtopics, talk about validation plan, ML system design, and finally completing with the potential risks in production. Moving on to the next slide, this is the agenda that we have for today. Let's start with opportunity evaluation. So what is the problem here? So as we all know, today supply chain issues are talking widely, especially after the COVID pandemic. The reason is that the systems that what we have today was not capable enough of predicting the discrepancies in the last mile logistics at a well-known scale. So why there is a problem today? Most of the people today rely on the online world, which means that the global e-commerce sales is expected to reach about $6.54 trillion by 2023. And the last mile logistics basically represent 53% of the total logistics cost in the e-commerce sector. And the other report from McKinsey says that 25% of customers in United States would abandon a purchase if same-day delivery was not available. So this truly means that people do care about the last mile logistics and they are very much concerned about the delivery time. And after the advent of Amazon and the same-day delivery, the customer expectation has soared so high that people want the same day delivery or the minimum 2-day delivery and a complete visibility or the tracking for their packages. And today, if you see, there is no straightforward solutions that are available in the market that would actually help the small business owners or medium scale business owners or even the large scale retailers to let them know or have the visibility on the packages that they ship to their customers. This is a huge problem today in the e-commerce sector space, and let's see how ML can help us in order to exactly predict the delivery time in the last mile space and how this would be capable to get more customers onboarded. So one of the other questions that we should always think is whether the ML can help solve it. Yes, with the history of deliveries that's actually made, we should be able to predict how much of time would be taken for packages to reach between point A to point B. Moving on to the next is the CRISP DM data science process. So let's take a look at it. So the first thing that we would start with is the business understanding. Let's start with the problem. So who's going to be the target user? The end customer is the target user in the e-commerce space who's actually expecting the package after placing the order in the site. What is the problem today? The problem today is that customers don't have visibility on the expected delivery package for their orders that they have been placed on the e-commerce site, and we are trying to bring visibility into that space and why it matters. As already said, customers want to have a complete visibility on the delivery time and when it would be delivered, because most of the people live in the urban areas these days, and for urban living areas, whether they live in apartment or high-rise buildings, there would be one small place where they would accumulate the parcels, and they really want to have a visibility of when the package is going to come so that they can prep themselves in prior, whether it is from a locker or a pickup point, or probably that's the front desk of the apartment or the house. What is the current state? So the current state right now is that all the supply chain or the 3PL companies that does the last mile logistics, be it a regional carrier or a national carrier, they rely on different carrier services for their last mile delivery. They don't exactly know what is the delivery time is going to be, but they just rely on the time that was provided by their last mile provider, and that in turn is being provided to the customer, which is not a great way of giving visibility from a customer standpoint. So let's start defining the success. So how the success would look like. So the success would look like customers being happy with the service that's provided by the e-commerce company. They would very well in advance know how the estimated time is going to be, and we are going to predict the delivery time in terms of hours and minutes. The target is going to be better customer service and retention of existing clients, and because of this there's going to be a word of mouth, and we would have new user base improvement as well. And what is the constraint that we see today? Prediction must be delivered to the customers at least half a day in advance so that they can plan, right? In case if the package is going to arrive by today evening, we should let the customers know in advance so that they can plan for the day. So that's a constraint that we have today. And what are the factors that we would identify? Transit times are provided by the last mile carriers, service levels, zones, distance, traffic reports, and distance between the locations. All these things would play a major role in predicting the delivery time. Let's talk about the data understanding. So the data understanding comes to a point where you would talk about the source data and what are the considerations and the validations that you would have to make. So the source data is going to be historical delivery data, GPS tracking data, traffic data, weather data, geographic data, customer data, seasonal data, and external APIs and data sources. We have to consider all these different varieties of data into the model that we are going to make. The reason is that this is going to have a huge impact on the prediction model that's going to give you the output. And data validations would be basically updated GPS data and traffic patterns. That has to be updated every single time because that's in the web and we rely on the web or probably an API that would give us this data, and that has to be constantly updated. And how does the data preparation step would look like? I would honestly classify this into 2-3 different steps. One is splitting the data, selecting the features, and preparing for modeling. So when we talk about split data, so for example, if we have 1,000 samples, data has to be like split into 80% into the training set, 16% into the validation set, and 4% into the test data. And features, the input features are going to be pretty straightforward. You would know exactly the distance between the two different locations. In the supply chain world, we call it as zones. So zone 1, zone 2, zone 3, up to zone 8 or 9. And you would have weight. What is the weight of the package? The traffic conditions, everything is normal, or is there any kind of traffic stuff or traffic contingencies that's in place, or probably if a highway is closed, how these things have to be factored into the model in prediction. What is the delivery location, preferred delivery time slot, holidays if any? Yes, that's going to have an impact. Weather condition, road condition, everything would come to the picture. What is output feature? Output feature is very strict and straightforward. It's just the delivery time. How would you prepare for modeling? So we would use the linear regression model. So linear regression is a simple and interpretable model that assumes a linear relationship between the input features and the target variable. The target variable is going to be the delivery time. So it can work well when there is a clear linear pattern in the data and the number of features is limited. Yes, that's what we have in the case. We knew the exact number of features, and we know that all these features are going to have a direct impact on the output. Moving on, how the solution validation plan would look like. So this is going to be an iterative test, as we already knew that machine learning models are all iterative. So we will evaluate the performance of the trained model on the validation set using appropriate evaluation metrics like MAE, MSE, which is nothing but mean absolute error, mean squared error, root mean squared error, and R square. So all these are like different statistical methods that we would use to basically train and validate the data. So the iterative test consists of 5 different things. One is the baseline model. So we would first start with a heuristic or a rules-based model to predict the delivery time, upon with which we would compare against the model that we are building. Heuristics rules could be the average delivery time calculated from the past data for every service and zones. And that would serve as a baseline model where we will compare the actual model with. So we have different techniques like cross validation. Basically, you split the data set into multiple folds and train the model on different combination of these folds. Hyperparameter tuning, perform a hyperparameter research using techniques like grid search, random search, or Bayesian optimization to find the optimal combination that maximizes the model performance. Similarly, feature importance analysis, remove or add features based on their importance to prove the model accuracy, or simplify the model if some features prove to be relevant, which we would ultimately know as we go along the iterative test. And finally, the error analysis, which would basically examine where the model prediction deviates slightly from the actual delivery time. Right? We will compare the actual delivery time to the ones that is given by our model, and we will come to a conclusion on how we can still enhance the existing features or enhance the modeling techniques that we use today, and can get to a better place where we get the numbers more close with each other. And how the ML system design is going to look like. As we all know, there are different ways of designing the system, and I have taken this to be a cloud-based model. The reason because the reliance of the internet connectivity is accepted. There's no problem with it. Low latency. Users will be comfortable sending the data to the cloud. There won't be any kind of privacy issues when it comes to the data in terms of delivery time. An offline model, offline learning should be more than sufficient enough, because delivery time prediction can be an offline model. Offline learning model doesn't need to be an online one. And similarly, batch predictions, because we can run these models on scheduled periods and update the delivery times. It depends upon how well the model behaves, and we can change these rules moving on. And finally, talking about the potential risks in production, what I see here is there is a high possibility for data drift and concept drift to happen. The reason being, carriers change their rates and services twice a year, which is called the general rate increase in the carrier. That has to be updated and reflected in the model that we have, number one. And zone changes do happen. So if the zone changes, then there would be definitely a change of distance too. That's how the carriers calculate the cost and the service levels. So the products that they offer is going to have an impact on the model that we have today. And every year there is a huge number of players who are getting into the market, especially in the last mile logistics. Previously, we just had truck delivery or milk van delivery, but these days we do rely on drone based deliveries. There are players like DoorDash who are getting into this market in terms of pickup returns, right? So those things has to be considered on a yearly basis. And finally, the customer preference change. So today, if the customer is expecting to know the exact delivery time, like at least half a day in advance, probably in 1 year down the lane, they may probably like to know the delivery time while they place the order. So those things have to be considered into the fact when we do this kind of machine learning projects. Thank you so much for listening to me, and please let me know if you have any questions. Thank you.